Hi, this is Mark. In this video, I'm going to show you an interesting way to derive the vertical distance of any triangle inscribed within a circle. So, if you take you start with a circle, and from here, we're just going to cut it in half. So right here, what we notice is if we break it into n segments, let's say we break this into n segments, we're going to let this distance be delta x. We're going to let it be equal to 1 divided by n. So typically when we have a function 1 over n, so we're going to have y 1 over n. Here's the n-axis. Typically looks like this. And so it converges towards the n-axis in this case. The distance gets smaller and smaller and smaller. So as n tends to infinity, these sections, it gets more precise. So essentially what we're going to do is we take this projection. So we're going to take that projection, and essentially what we have is we have two triangles that we can connect. So if we connect this node, we have that triangle, and then we also can connect at this point. So what we're trying to find is this delta y. And essentially what this accomplishes is we want to find the unit length. So if we have like any angle theta, we notice that this is proportional to delta n. So theta is going to be proportional to delta x in this case, which we know is 1 over n. And then we know a few things. As n approaches infinity, theta approaches 0. So of course, in the initial case, when n equals 1, let's suppose we let radius r equals 1. Well, then we basically just have the line, but then when we make n equals 2, we have 1/2. So then we make the projection and we connect that 1/2. So in order to, although like this could be, n could take any real number, so we don't necessarily have to make it, if we want to make it cut into a smaller and smaller segments, we could do so. But so essentially what this is right here, if that's 1 over n, this is 1 minus delta x. Okay, so right here, we're going to calculate, we have 1 minus delta x. This is 1 minus 1 over n, which is this n minus 1 over n. So that's 1 minus delta x, and that gives us the initial relation, and we know the radius is 1. So we can actually calculate delta y. So what we do is we construct theta. Let's just say this is n minus 1. We have delta y and we have 1. So using the Pythagorean theorem, we have n minus 1 over n squared plus delta y squared is 1 squared. And therefore delta y squared equals 1 minus n minus 1 over n squared. Well, this equals 1 minus, and then up top, what we have is n squared minus 2n plus 1 all over n squared. All right, so then we can cross multiply. we end up getting n squared minus 2n plus 1, all divided by n squared. And then we cancel these two, and we're going to cancel the n squared, and we transfer a negative to the fraction, and we end up getting 2n minus 1 over n squared. So for this relation, what we notice, so that gives us the that gives us the distance, so delta y, and see. So essentially right here, if we let, like, for instance, let's let n equal 1. So then we have delta, oh yeah, I forgot to mention. So we know delta y is the root 2n minus 1 divided by n. So it's the square root. So if we let delta n equals 1, we have then delta y is just the square root of 1 over 1, which is 1. So what that means right here, so if n equals 1, 1 minus delta is 0, and okay, so what we're actually calculating is this length, which is 1. So now let's let n equal 2. Square root of 4 minus 1 is root 3. Oh, root 3 over 2, that seems familiar. Well, if we cut this into half, so what we do is we cut this in half. So if this is 1, we have 1/2. Project. So that makes the projection, and therefore theta, we have theta, so we have some triangle, root 3 over 2. This seems like 60. Yeah, that's this 1/2, so theta is 60 degrees. So we found the 30, 60, 90 triangle relation right here, and we can do so. We can basically make n any value and get, you know, all of these components. So, you know, it's interesting because what is it? Trying to think. Now, if we calculated the other triangle right here, what we end up finding is for the first iteration, like if we were to calculate that, for instance, so what do we have? We have 1 over n. This is length, and we have delta y equals root. So basically, therefore we have L squared equals 1 over n squared plus root 2n minus 1 divided by n squared. That's 1 over n squared plus 2n minus 1 over n squared. So the 1's cancel, and we're left with equal to 1 plus 2n minus 1, because common denominator. Cancel the 2, so it's 2n over n squared which is just 2 over n. But then when we take L, is the square root of 2 divided by n. And what we're actually calculating right here is this distance. L. So, now we constrain, if we let n equal 1, remember we have this point, then L, let's just say L1, is square root of 2 divided by 1, which is square root of 2. So that's the, what we know, the relation. If radius is 1, that's our 45, 45, 90 triangle. So we know this is root 2. But then we go iteration, let's say 2. We know we let n equal 2. Then L2 equals, in this case we have root 2 over 2. So it has to be square root of 2 over 2. So in that case, I believe, let's see. So we have, so this is cut in half. So this would be, this line segment, projection, and then we get root 2 over 2. And I believe if n equaled to 4, so in this case we have 1/4 of the way. So it's basically a section that this is cut in half. And that gives us actually root 2 over 2. So that's the typical relation that we find at a 45-degree angle, but the projection is from this side. So when we have a 45-degree angle. So basically, yeah, this gives us the length of any given, but it's basically this length is actually how you find the circumference. So basically, as n approaches infinity, or as n approaches infinity, actually what happens to this is the length approaches 0. So for this case, it's like we have as a function, y is this root 2. I believe I did that right, so it's L squared. So it's root 2 over n. And of course, like if we start with 1, we have root 2. So essentially it spikes up like this. And it's just going to go down like this. But as n approaches infinity, this distance is going to approach 0. So there you have it. That's this relationship to find if you want to find the vertical distance along a triangle, or if you want to find the theta or the angle, you can use this relation, and basically n could be take any real number, and then you can locate the distance, or this is delta y. I hope you enjoyed.